So I will share my screen. And I will warn you guys that I will call on people ahead of if nobody's answering all my questions. So welcome to class 2. You all survived the first one. Getting over the hump of your first lesson in coding is one of the biggest things, I think. And now it's kind of all about just banging your head against the computer time and time again until you kind of start to get the hang of it. So I want to start by just going over the 4 components of coding that I talked about last time. So I looked up actual definitions this time rather than my made up definitions. So I'm hoping that some of you are willing to offer up your own understanding of these. So is anybody willing to take a stab at what an operator is?
I can take a stab at it.
Great.
Is it something which acts on like an and or an or? It's either a Boolean or it combines or otherwise manipulates a variable. That's a terrible definition, I'm sure. But
no, that's the gist of it. It's something that's like a simple. It performs simple operations on the variables, and so it's a simple type of function that takes 1 or 2 arguments. Usually it's just taking the data, changing it in the only way it knows how to change it, and outputting new data. And there's no parentheses for them, which is kind of the big giveaway. Variables are the containers for storing your data values. And they're really kind of like one of the most important things. They're also fun because you get to create your own names for them. Somebody want to take a stab at functions? Max, I know you're really excited to do it, but you gotta temper your excitement and let somebody else answer. Clara, are you there and able to take a try?
Sure. I just have functions as like the tools for, like from what you said last week, tools for changing data. So it reminds me of like putting multiple operators together sometimes.
Yeah, that's great. Yeah, so they're code written to carry out a specific task. And yeah, so they're meant to change the data, and they're usually more complex. And yeah, you could have it be like a short thing that it's carrying out, or it could be hundreds of lines of code that are all just getting activated by that one word, the parentheses. And these take arguments or parameters, which allow you to have them do different things depending on what specific case you're using it for. And then somebody take a try for what a package is.
Isn't a package like a group of functions kind of that it's like organized in a certain way so that they can, I don't know, do more things and like build on top of each other kind of?
Mm-hmm. Yeah, exactly. I knew you all knew these. Yeah, so collections of functions. Technically, they can also have data, and they always have documentation with them. And there's a well-defined format in R for making a package. But yeah, really the key is that is generally these functions are going to be all sort of built around doing similar things. And last time I promised that I would try to be more of a do first, understand later teacher. So we will open up R. So if you're able to go ahead and open the file that is in that zip folder called class 2 exercise 1. And I was going to maybe do breakout rooms, but since there's only a couple of us, we can just take a couple of minutes to try answering each of these little exercises on your own. And if you get stuck on something or have a question, just feel free to ask. Also, and then if you feel like you got the right answer for all of them, use the reactions thing to put your hand up. So that way we'll know that when people are finishing up. I'll also cut us off because the last one's kind of hard. So if people aren't getting that one.
Sorry, where can we find exercise 1? I downloaded the zip file, but I don't see it as its own like document.
What do you see in the zip, or what's the name of the zip file that you downloaded?
Class 2 transform data. Or I guess I downloaded the whole class 2 data transformation, and inside it just has class 2 and like the slides, and then
Yeah,
it
so
says class 2
so
transform
then
data zip.
yeah,
Okay.
so then there's another zip inside. Yeah, zips and zips, and so it should be in that second one.
Okay.
Max, glad to see your hand. For everybody else, can you do a thumbs up if you've done the first two? Cool. Max, did you get number 3?
I kind of, there's a space between the words when it joins together, but it did at least concatenate them mostly.
What did you, can you describe what you typed?
Yeah, I had to cheat for that one. Used the paste function. I tried append and I tried concatenate from what I knew about other programming languages, but neither of them worked for me.
Cool. So did you do something like paste? Oh. Paste.
Yep.
And then
just quotes for both of them with a comma between them.
Cool. Yeah, so that's exactly the way that you'd want to do it. And hopefully some people tried doing Wanda plus vision, which is wrong because those would be objects. So you'd want to try doing them in quotes, but that's also wrong because they're non-numeric arguments, which gets at something really important, which is that for number 1 and number 2, you're using the arithmetic operators to operate on numbers, but those won't work for this other type of data called a string, or in this case, a character. And I'll talk a bit more about that. For these first two, does anybody have questions on them, or do you feel like you got them? Cool. So can somebody just real quick also remind or tell us what 2 characters you use to assign a value to a variable?
Everybody's got it in chat.
Oh, nice. I should make it so I can see the chat. Glad everybody's got it. So the thing I wanted to do with this other script, so this is a script called graph study attrition. So you can open that one up yourself, and I wanted to have us just go through and everybody point out a couple examples of operators, functions, and variables that are in this script. So whoever's daring enough to go first, can you go and then call on somebody else to go next? Shika, any chance you'd be up for going first? Or somebody else?
Andrew, can you repeat the question?
Yeah. So just giving examples that you see in the script of things that are operators, things that are variables, and things that are functions. And just like, for example, library here is an example of a function, because you can see that it is using those two parentheses to operate on this. Anyone else willing to take a stab?
I'm going to say ggplot is a function.
Hey, Dan, you are correct. So that's another example of a function, and it's got those parentheses giving that away. It's also got a bunch of attributes in it that are, or not attributes, arguments in it that are being passed to the function. Somebody want to give an example of an operator? I also can't see the chat, so I don't know if.
Would an operator be the subtraction in the create a new column, subtracting the number, and then like doing the MBI intent to treat minus MBI post treatment?
Yep. So yeah, that right there is a great example of an operator using, in this case, subtracting that column, or subtracting this column from that column. And then would somebody take, you're willing to list a variable that they're seeing?
Is assigning y to age a variable?
Y to age. What line are you looking at? Oh, right here.
20.
No, that one is actually an argument, and that's a kind of important distinction, but a little more nuanced than I've gotten into. But that the y there is an argument for this aesthetics function, which is a part of the ggplot function. So this one's complicated, but you know that it's generally, if you're sticking to how the tidyverse sort of norms for using the operators, the equals here is used for when you're assigning a value to a parameter, which y is a parameter, but the assignment caret with the dash is when you're making a variable. Somebody else want to try one of picking out a variable? Max, you got one for me?
I just want to clarify real quick that AES thing inside ggplot is kind of like a lexical way to say we're going to set the x-axis to MBI attrition and the y-axis to age. So the equals is passing in those x and y parameters. Yeah.
And for a variable, would small attrition df be a variable?
Yep. Yeah, perfect. So yeah, we're using the assignment operator there to give this word this value of whatever comes out of this function. So I'm going to just somewhat quickly go through these each step here, which I also did last time. And then I have a couple of slides which go into more detail about them. So the important thing that you always want to do is load in your libraries. I generally think it's a good rule of thumb to use tidyverse whenever possible. So I almost always have tidyverse loaded into my scripts. The next line here is using the read Excel function, and it has to have the path passed to it, otherwise it won't work. And so the file path that we're giving it is this string. And then this NA is an optional parameter that I decided to use, which tells it what to use for NA. The snazzy thing about this file path also is that it's called a relative file path, where using this period here and then the dash tells it to look in the directory that is the working directory. And so with R, when you open an R script, if you just double click on it and open it, it will set the working directory as the directory that that script was in. And so using these relative paths allows you to just keep your data and your script in the same folder, and then you can take that folder and put it anywhere you want and it will work. So that's why I'm able to use it here, and you all are able to download it from the website and use it straight off. When you're doing work like on the computers at CHM, you'll generally need to give the full path. So like study, AFCRON, intermediate data, and then your data file. So we're reading in our data, and you can see it shows up here as a data table called a tibble, and we're saving it to this name. If we just run it without that, it just outputs to the console here and doesn't get saved anywhere. This next one is using the rename function to change some of the column names. To make them snake case. And you can see that for tidyverse, you almost always, a lot of the functions the first argument will be the data frame that you're working with. And so you don't need to define it. And like, for instance, here I am defining which parameter I want to use. It works just based on place. So for these functions, the first argument that you're passing to it will always be, it will assume that it's the data frame. And then here we're assigning these new values. We're using mutate here to make a new column. And again, you can see that that first one is the data frame. We are calling that new column MBI attrition. And like I said before, we're doing MBI intent to treat. So that column, it's going to be hard to find it, so I'm not going to. But we're taking this column of data and subtracting this column from it, which in this study shows us how many people dropped out of the mindfulness-based interventions. This next one uses select to just subset the data and only take the variables that you're listing. So I listed these columns. I listed these 6 columns here, and you can see that I saved it to a new variable which has 6 columns. And that makes it easier to work with because now I see all the ones that I care about. And then this last one is more complicated, but it is the one that produces the plot with the MBI attrition on the x-axis and age on the y-axis. And so you can see those here. And like Dan said, that is a standard way of setting up those aesthetics, is what they call it. And with this, you can see that a lot of the studies in our meta-analysis had 0 or low attrition. So like those ones are all 0. These ones are in the 5 or so people dropped out, but you have some outliers that are skewing the data here. And so usually the way you do that, deal with that is by doing a log transformation. And that is going to be the homework, is to log transform this data. And then if you are all prepared to type along, actually, yeah, you can just type along for this. So here I'm going to use a new function called write CSV. And that function allows us to save a CSV file. And so actually, I don't want to use that quite yet. So with write CSV, because I have tidyverse loaded and this is a tidyverse function, R will help me out by showing me what the different arguments are for write CSV. So the first one is X. X generally refers to the data frame that the tibble that you're going to be working on. And then file is the other one. And so that's the file path. You can see that all the other ones have an equal sign, which is your clue that these ones are optional. So it's saying that the default for NA is capital NA, which is means that you don't have to put it in.
Andrew, can you show real quick, like if that tooltip wasn't enough help, how to get help on a function in RStudio?
Yeah, so say that I knew that I knew it's called like write something. I want to do a CSV, but like, I can't remember what the exact name is. You go over here to the help tab and to the search bar, and I can just type in write, and it gives me all the common things that begin with the word write. And so I can find write CSV easily. And then this gives all of the documentation. And write CSV is a little weird because it has a more generic form called write delim. But that just means that any delimiter, like in a CSV, it's a comma. It can handle any of those. So we'll do write CSV. We'll define small attrition DF as the data that we want to save to our computers. And then we'll copy in this name. And we'll use it for the file argument. And so I'm just going to define it. It's generally, if you are able to, good to define which ones you're using rather than just relying on the order. And so if you put that in and use command return to run it, you didn't get any error. I didn't get any errors. So that is a good sign. If you want to do some look around at the files in your working directory, if you go to the files folder here, you can see what's in your working directory. And you can see that small attrition df.csv is now saved to that folder. And so you could read that in if you wanted to. And for the homework, you will read that in. So if this line didn't work, then let me know right now. I have a couple slides that I'm going to try to go through fast because I don't want to take too much more time, but feel free to always interrupt me. So I hinted at data types before, and that question that Max nailed was meant to kind of get give you a sense of why data types matter. And so there's really kind of like these 5 are the main data types that you'll often end up using in R, and a lot of the functions can only work with a specific data type. So there's character data types like which are words or just any character that doesn't have like, yeah, just any character. And so these they always have quotation marks, and you can also do a single quote mark. Those work interchangeably in R. And you can see that it really doesn't matter what the characters are. So you can even have a numeric value in quotes, and then it no longer has its value. It's just treated as another letter, basically. And you'll also hear these called strings when there's several characters strung together one after another. And then numeric values are really these 2 are the ones that you use for a lot of your data. And numeric values here can, I think, be any real number. And these are what you'll use for decimal points. They can be negative numbers. Integers are a different data type in R, and the default is numeric, but integers, meaning whole numbers, you need to have a capital L afterwards to get R to make it into an integer. You can also use this as an integer function. And then there's another type called logical, and there's only 2 options for those. It's either true or false, and it has to be in all caps. And then there's also dates, which are very tricky to work with, and there's an entire package built in Tidyverse just to work with dates. And if you've ever seen data before, this is what data looks like. Data structures are similar to data types in that they are ways that you organize your data. And in R, you're generally working with vectors and lists and data frames or tables. A matrix and an array are a little more complicated, but basically what differentiates a matrix from a data frame is that in a matrix, all of your rows and columns have to be the same data type. So they can only be numbers if they're numbers. But you can see that there's the different colors, meaning that for a data frame, you can have different data types in a data frame across your columns, but not within one column. Well, vectors and lists are very similar, but also pretty different. So the vectors are basically just a bunch of data in a row. And so a vector always it can only be one data type. So and in R, you use C here to combine these into a vector. So all of these would be a vector, numeric vector. This would be cat, dog, bird would be a character vector. Lists are fancier than vectors because it doesn't matter what data type you have. You can have different data types. You can have lists of vectors. So this you use the list function to make a list. And so here the list has a vector as its first value, a vector as its second value, 4 as its third value, and so on. And lists, while seemingly simple, are kind of like underlie a lot of the more complex things in R. And then one that's really important to know for Tidyverse is a tibble, which is basically just a data frame, but it has some special properties that make it work better with all the different Tidyverse functions. So I'll be calling all of our data frames tibbles from now on. And so that's basically just anything that's columns and rows when you're using tidyverse. The real quick, you can see that for a tibble, which attrition df is a tibble, that when you expand it, well, when you expand it, each column lists is basically a vector, and it lists the type. So these are characters, age is number, numeric, and there are functions which allow you to check what data type you're using, or a variable is. So a lot of the time, especially early on, your errors that are popping up are probably going to a lot of the time be because you're trying to use a function on the wrong sort of data type. Oh, my computer's going slow now. The functions that I wanted to talk about, we've actually already talked about all of them in the script. So you already have seen how they work. And next time we'll talk about these other important functions that are also used for transforming data. And I have just details about each of them here because you will use these over and over and over again in your work if you're using tidyverse. And so we have some details about read CSV, and the full documentation is always available on the internet. And so when you go to the documentation, it's actually the same thing that was in that help section of RStudio, but you can see the function and then all of the arguments that it could possibly take. And you can see that file is the only one that doesn't have an equal sign. So that means it's the only required one. There's not, for write CSV, there's not really a tidyverse option for writing Excel files. So generally you want to try and work in CSVs or TSVs when you're using R. The other ones that we saw in action were rename, which changes column names and only has 2 required arguments, and then select, which also has 2 required arguments, and chooses subsets of columns from a tibble. Select also allows you to reorder columns of data. So if you wanted to change this data frame so that age was the first one, you could do that easily using select. And this is a fancy trick, but I always feel like generally you can try and code along when I'm doing stuff so you can see if it's actually working for you. If you use select here, and we want to make age our first variable, or our first column in the data frame. we can do age, and then we can use a function inside a function called everything, which then just takes everything else in the previous order. So when we do that, we get this new data frame where age,
You clicked on the wrong one.
where age is now at the front and everything else is kept. So, and if you go to the documentation for select, there's a million different tricks like that with different functions you can use inside of it, because it's easy when you're working with 6 columns, but when you're working with 600, you want to use a lot more automation. Mutate is the last one. And I have a picture here of a mutated fish that was found in Lake Monona. The mutate is also one that seems simple, like it just allows you to make a new column, but you can do so much with it. And so in the homework, you'll use it to create that new log column. And it takes name value pairs. And so what that means is where am I at? Mutate. A name value pair here is you have the name, and then you're doing equals and then giving it a value. So in this case, the value is this column minus this column. Yeah, that subtracted from that column. But you can get a lot more complicated with how you create new columns. And cheat sheets are the last thing that I wanted to talk about. So on the OSF page, I compiled some cheat sheets for y'all, which are generally in order of like more common to more nuanced and complicated. But if you open it up, there are these cheat sheets are basically like all the important functions in these key tidyverse packages. So it's really helpful when you're starting out, and it's still always really helpful to have these on hand, like put them on your desktop or something so that you can just pull them up whenever you're coding, and you can use them so that you don't have to memorize what the names of all these functions are. So say that you want to import data, you have all of the main data types listed here. You have the useful arguments. So like in this, you can say that it's doesn't have a header, things like that. And the dplyr cheat sheet is going to be really handy for you, especially for the homework, because dplyr is the package that has all of those functions that I just went over. So you can see that it has actually tidier and dplyr. So tidier has a lot of those important functions as well. The ones though that I just showed you are ones like select or mutate, rename. And so you can see there's a lot of other options for ways that you can change up data. So that's everything that I wanted to cover. Sorry, it's a bit more today than the first day. There's another, so that cheat sheets, those are on in that same folder that everything else was in. And your homework is also in that zip file, which if you open it, it has just commented step-by-step instructions to write your own script and change this data in order to log transform it and make it a better graph so that our data is not being influenced, or at least the visualization, by the outliers. Any questions or concerns before I stop the recording here? Cool. So I'll stop sharing and stop the recording.